Good morning. This is Introduction to Algebra for April Fool's Day. So Wednesday, April Fools. Don't play any terrible jokes on your families. Be kind. Okay, let's look at what we're going to talk about today. We're going to talk about adding like terms. Now, I like fruit. I like all kinds of fruit. But there's a difference between an apple and an orange. They taste different. They look different. Their textures are different. But sometimes we look at things and we say, oh, this is an orange and this is a tangerine. Or this is an orange and this is a kiwi or a cutie. Okay, they look very similar, but they're not the same thing. When we are adding like terms in math, they have to be the same. I'm going to show you exactly what I'm talking about here. It's very simple. It's not a difficult task today. We're going to start with the easiest one on this, okay? We're going to start with combining our numbers. If we look at this problem, x, and remember when an x or any letter is standing by itself, it has a coefficient of 1. The coefficient is simply this number in front of the letters, okay? When we are determining if two terms, a term is the coefficient and the letters from the beginning to the next process. Here's an addition sign, so this is one term. From this addition sign to this subtraction sign, this is one term, okay? The whole thing has to be looked at as one thing. Now, when we're looking at terms, we do not consider the coefficient, okay? In other words, the number that's in front of the letters, we don't care about that. We only care about the letters and the exponents when deciding if we can add them. Okay, let's look at our first thing. We have x plus 2y plus 3x plus 5 minus 7y minus 2. Now, there's a couple of things in here. Their values are set because they are constants. That means they're just a number, okay? That is the number 5 and the number minus 2, okay? So we have 5 and minus 2, so that is a 3. And we've used those two. I'm going to mark them out. I don't suggest you do this after you get good at it, but when you're starting, it's not a bad idea, okay, to help you just make sure you've used everything until you've done it a few days. Now, typically, whenever you do this, you want to do these in alphabetical order. You don't have to. You can do them in reverse order. You do them in ascending or descending order, but we want to make sure that they make logical sense. So I'm going to choose to do the x next, okay? X and 3x. Okay, now we know that this x really means 1x, so 1x plus 3x gives me 4x. And again, I'm going to mark those off just so I know that I've used them. Now I have y's, 2y and minus 7y. So what is 2y minus 7y? It is a minus 5y. So there's my answer. My answer cannot come to a constant number at the end like 5 or 143 because I don't have the values of x and y. Now we'll get to that. We've solved some problems like that and we'll do these again. Today we're only trying to get them to combine correctly, okay? I want us to look over at this problem. 4xy and 6yx, are those like terms? Can I combine them, okay? The first thing I'm gonna do is ignore my coefficients. So I'm only gonna look at x, y, and y, x. Now, this one is not a very complicated one, so I can look at that and say, oh, well, I know that 2 times 4 equals 8, but 4 times 2 equals 8. In other words, it doesn't matter which order I put those two factors. I'm going to come up with the same product. This is going to be true of xy or yx because these two letters side by side mean that they're being multiplied. So I can multiply them either way. So they are like terms. They're just written, we would say they've written the twin if you were doing this in lower elementary for multiplication. Now, what if it was a little more confusing and I was still uncertain if something were like terms or not? How could I solve it? Assign the letters a number. For example, let's assign 2 to the letter X. And let's assign -3 to Y. It doesn't matter the number. That's not the important part. The important part is that each letter is given a number, okay? So now just substitute it in. X is 2, Y is -3. So XY would equal -6. Look at your other one using the same values. Y is -3 and X is 2, giving me the answer of -6. If they are like terms, this number will be the same. Now again, it doesn't have to be -6. I could have assigned these numbers, the numbers 2 and 5, or 1017 and 969. I don't know why you'd want to make yourself do that much math, but you could, okay? So we just use 2 and 3, 2 and -3 to make it easy. So, but these two terms, remember the coefficients don't matter. We're only looking at the letters. Since they came out with the same value, these are like terms. Now, I don't need to do this every time. I need to do this when I'm not certain, okay? Let's look at this next one, and let's talk about what it means. 2xy squared and 3y squared x and 7yxy. Are they like terms? Well, the first thing we're going to do is forget the coefficients. We don't care about the coefficients, okay? And now, because we have some of these that have powers, we're going to break them apart. What I mean by that is we're going to say, well, there's an x, then there's a y squared. Well, what does y squared mean? It means y times y. So I'm going to put y times y. Then I'm going to go over here, and again, I'm going to forget the coefficient, looking only at my letters. I'm going to say this is y squared means y times x. And look at the last one. 7yxy. Drop the coefficient and write the letters. Y, X, Y. Now, I can go back, and I'm going to use a different colored chalk just so you can see it a little better. I'm going to put them in ascending order. I'm going to put them in alphabetical order, okay? So X comes first. So this is X, Y, Y. This is X, Y, Y. And this is X, Y, Y. So all three of them actually mean X, Y, Y. So that means that these numbers, these terms are like terms. So I can add them together. How do I add them together? Well, I don't have to worry anything about these letters. Okay? I don't need that. All I need to do is decide which way I'm going to write it. Well, I'm going to write it this way. XY squared, because each of these mean XY squared. Okay, so I'm going to write XY squared. Now, I'm going to go back and add my coefficients. 2 plus 3 is 5, plus 7 is 12. So this equals 12xy squared. Okay, all we have to do is add the coefficients once we know that all of the letters are like terms. Let's look at this next one. 3yxy plus 2xyx plus minus 6xy squared plus 3y squared x. I can't read it today, all right? Now, so the first thing I'm going to do is I'm going to put them, because this is easiest for me, is to make them the same. Now, how do I do that? I need to look at those and say, I'm either going to break them apart, which is the way your book teaches you to do it, or I'm going to condense them so they all have powers, okay? One or the other. I'm going to put this one in powers, okay? So I'm going to say this is 3xy squared. Does everybody see how I did that? I kept my 3. There's only one x, so I brought it down. There are 2 y's, so I made that y squared. Because y squared means y times y. Okay, now I'm going to go to the next one. Okay, and it says 2. Bring the coefficient down. Look at the x. In this case, there are 2 x's. So I'm going to say x squared y. Okay, go to the next one. I have a minus 6 as my coefficient. I have an x and a y squared. Nothing to combine, so I'm just going to bring it down. And on the last one, I'm going to switch the order. I'm going to put the X in front because I've had the X in the front the whole way. And remember, when you switch the order of two letters with inside a term, you're not changing its value, okay? Here we go. We're going to now look for the ones that look exactly the same. X, Y squared. Well, that's this one. It is not this one. It is this one, okay? And it is the last one, okay? Now, using their signs, the sign goes with the coefficient. So we have 3 minus 6 gives us a minus 3, plus 3 gives us 0. Since we have 0x, y squared, that would be a 0. Because if I multiply 0 times x, that answer is going to be 0. And then that 0 times y squared, it's still 0. Okay, because 0 makes everything a 0. All of this then goes away. It's canceled out. All I have left in this problem is 2x squared y. Let's try this one over here. We have 3x squared plus 2xx plus 4x plus 7 plus 3x. Okay, let's break it apart so we know what we're looking at. We have 4 plus 3xx plus 2xx plus 4x plus 7 plus 3x. Okay, what are you going to do first? Well, let's first try to combine all of our constants, okay? Our constants are going to be the 4 and our 7. Well, 4 plus 7 is 11, okay? Now, after we do that, let's go back and add just our x's, okay? It has only one x to it. So we look at it, it says 4x and 3x gives us plus 7x. How many are squared? Okay, we have 3, because there's 2 x's and this has 2 x's. So we have 3 and 2. This gives us 5x squared. Now, there's nothing wrong with this order, okay? But normally we are going to put our constant at the end, but I'll explain that as we go a little further. Let's look at this one up here. 4x plus 3 plus 6x plus 4 plus 2xy plus yx plus 2. Okay, let's do our constants first. Going through here, I have a 3 and a 4 makes 7 plus a 2 makes 9. Okay, now let's go through and find only our x's. 4x and 6x is 10x. Now we have xy and yx. Are they the same term? They are like terms, okay? So I'm going to say 2 plus 3 is plus 5. When I write this down, though, I need to make them the same, so I'm going to make them x, y. I'm just going to invert that one, okay? And that's all of them. So today, on your piece of paper, let's look at one. Write this down for me. How about you write AB squared, B A to the third power, B A to the fourth power. There's no processes in that problem I gave you. It's just a bunch of letters, okay? Because I want you to combine your A's and B's the best that you can, okay? Let's look at that again. It's AB squared, then it's I'm sorry, I can't see the book there, B A cubed, and our last one is B A to the fourth. What can I combine? Okay, first I can combine all of the A's, because all of this, there's no processes in between, so all of this can be combined. So I have 1 and 3 and 4. So I would say A to the 8th power. All I'm doing is adding the powers and simplifying this term. Here I have a B that is 2 plus 1, so it is to the 4th power. So my answer is a to the 8th, b to the 4th. Write this down. Let me erase this real quick and I'll write it with you. Okay? It is y x squared, y to the 3rd, y, and then y to the 4th. What can you combine? Well, there's only one x, or x squared. Then we have a y. We have 1 plus 3 plus 1 here and 4 there. So now we have 1, 4, 5, and 5 plus 4 makes 9. Notice that there's no coefficients in this term. I'm simply adding the number of y's. You say, well, how did you do that? How did you know? Okay, if I wanted to write this all out, I could write y, x, x. Now there's 3 y's, 1, 2, 3, 1 y. Now there's 4 more y's. Now I would simply add them together. Okay, here's the x. Well, x times x is x squared. Then I have a y. 1, 2, 3, 4, 5, 6, 7, 8, 9 y's. So I put the 9 there. Okay? I'm adding, so when they're just letters, I'm adding the exponents. Now, if I have coefficients and I have 5xy right now, and I'm adding that to an xy, then I add the coefficients. I'm just adding them. Here I'm changing the exponent. Okay? Let's write this problem down. What if you had, I'm going to look at number 25 in your book. Okay? Number 25 in your book. It says a to the 3rd, m to the 3rd, a, m to the 4th, a squared. Okay? So what are we going to do? We're going to combine the a's and m's that we can. So let's put an a. Now let's combine all of the a's. We have 1 plus 3 makes 4. This makes 5. And 2 more makes 7. What about m? I have 1 plus 3 makes 4. Plus 4 makes 8. Okay? Now let's try one like term. Let's see if they give us one in our homework today. They don't actually. So as long as you're understanding how to combine these terms, that's all there is to this today. Okay? And tonight, I want you for homework to look at page 286. I looked at the wrong page. Let's look at the top of 289. I'm sorry. There are some practice ones there. If you want to do the practice, we've done 2 of the practice problems already. If you want to do the others and shoot me a text and make sure you're doing it right, you may. I would like for you to do your homework today online. Follow the directions. It's not every problem in our problem set, but what I have you do is work it out on your paper. You'll enter your answer online so that I can get your answers back. I did mark it so that it will tell you right away if you're right or wrong. One of the last questions will be, which problems would you like me to re-explain? So think about what you're putting on there, okay? Do your best. Remember, Thursday is the day we need to get all of our work turned in.